Part 1 here is pretty straightforward. We just need to make use of the results that we have in our formula sheet. So for integration of 1 over a square minus v square, this will just be equal to 1 over 2a ln of the modulus of a plus v over a minus v plus an arbitrary constant c. We are given this differential equation, and since we are supposed to show this, that will mean that we need to solve this differential equation. It is the kind of differential equation that we have mentioned in our topical outline. It is a variable separable kind of differential equation because we have v here and we have v here. So I'm going to divide this across to the other side, which will give me a 1 over a square minus v square. Then dv dt. For this constant, I'm going to bring it over to the other side. So 10 over a squared. And integrating both left and right hand side with respect to t. On the left hand side, we will be left with a integration of 1 over a square minus v square dv. And this is a constant, so I'm going to leave it outside the integration notation. We'll be integrating 1 dt. So integrating this, we have actually done that in the first part of the question. So it is going to be 1 over 2a ln of the modulus of a plus v over a minus v. This is equal to 10 over a square t. Then plus an arbitrary constant, I'm going to go for an uppercase a. I'm going to move this over to the right hand side. So we have a ln modulus of a plus v divided by a minus v. This is equal to 20t over a, then plus, this is going to be 2a. And this is actually pretty good because 20t over a is actually part of what we are supposed to prove here. What we need to do next is to probably solve for the arbitrary constant because we do have a set of information that is given to us between v and t. And that set of information is here. The question says that the object is being released from rest. That means when t is equal to 0, v is equal to 0. I'm going to be using that, but I think I'm going to delay that a little bit. Let me re-express it without the modulus first before I substitute in the v is equal to 0, t is equal to 0 to solve for our arbitrary constant. So removing the ln from the left-hand side, so we will have a modulus of a plus v over a minus v. This will be e to the power of this, which I'm going to write it as e to the power of 2aa, e to the power of 20t over a. And removing the modulus, we have a plus v over a minus v. This is equal to plus minus e to the power of 2aa, e to the power of 20t over a. And I'm going to rewrite this. I'm going to rewrite this as b e to the power of 20t over a, where it is pretty obvious, but b here is going to be representing our plus minus e to the power of 2aa. So this is a better arbitrary constant to be working with instead of this. And now I'm going to do the substitution, which means that when t is equal to 0, v is equal to 0 because the object is released from rest. So when t equals to 0, v is equal to 0. On the left hand side, we have a plus 0 over a minus 0. On the right hand side, it is going to be b e to the power of 0. This tells me that e to the power of 0 is 1. So on the right hand side, we have a b. And on the left hand side, it is a over a. So b is equal to 1. And now we are ready to try to make v the subject, and we are going to try to show that it is going to be equal to this. So let me rewrite this. It is going to be a plus v over a minus v. This is equal to e to the power of 20t over a. So cross multiplying, we have a plus v. This is going to be equal to e to the power of 20t over a times a, then minus v times of e to the power of 20t over a. And I'm going to move the v over to one side. So moving it over to one side, we will have a v e to the power of 20t over a plus v, and moving this over to the right hand side and factorizing out a at the same time, we will have a e to the power of 20t over a, then minus 1. So now if I were to make v the subject by dividing this over, because if I were to factorize out v, what I'm going to be left with on the left hand side here is going to be a e to the power of 20t over a, then plus 1. And multiplying by the numerator, a I'm going to be factorizing out. So we have a e to the power of 20t over a minus 1. And this is what the question wants us to show. And now we are given that a is equal to 2. So when we are given this, we will actually be able to find an expression of v that is now independent of a, because we can replace it by 2. So v is 2 e to the power of 20t over 2. That will be e to the power of 10t. Then minus 1 divided by e to the power of 10t plus 1. And what is v? V is actually the rate of change of the displacement. So v can be replaced by dx dt. So dx dt, this is equal to 2 e to the power of 10t minus 1 divided by e to the power of 10t plus 1. And we are supposed to find the value of x when t is equal to 1. And that can be found by doing a process of integration. Because if you were to look at the question, x is measured from the point when the object is first released. That means when t is equal to 0, x is actually equal to 0. So by doing an integration, when t is equal to 1, we will be able to find x by integrating it from 0 all the way until 1 of this. So it is going to be 2 e to the power of 10t minus 1 divided by e to the power of 10t plus 1 dt. And pressing this into the calculator will get us our answer, and it is going to be equal to 1.723 meters.